Hello friends, in this video we are going to learn a new chapter which is added for CBSE 9th state 9 how forces affect motion. So please watch the video. We are going to cover all the important concepts like what is force, types of forces, what is friction, what is inertia, types of inertia, and Newton's three laws of motion. And finally we will discuss about the linear momentum and impulse also. Is it clear? So what is force? So force generally it is defined as push or pull applied on an object. You shall know force is what? Push or pull. And SI unit of force is what? Newton. Is it clear? You can see the definition. It is defined as the push or pull applied on an object. SI unit is what? Newton. SI unit of force is what? Newton. And CGS unit of force is what? Dyne. Okay, there is a relationship between SI unit and CGS unit. What is the relationship? 1 Newton is equal to 10 to the power 5 dyne. Am I clear? Now we have to know what are the effects of forces. Okay, see, there are certain effects of forces like a force tries to change. Okay, the state of an object. Okay, state of the object means if it is at rest, if you apply the force, it may come into motion. Is it not? Position of an object, shape and size of an object, and direction of an object. Is it clear? So these are the effects of a force. Okay, you can see, you can take a paper, if apply a force, the shape and size will be changed. If a football is coming towards you, if you kick the football towards right side, it will start moving towards the right side. So it can change the direction. Am I clear? So like that, effect of force you should understand. Next, we talk about two types of forces, balanced force and unbalanced force. Okay, what is balanced force? If n number of forces are acting, okay, on an object and resultant force is what? 0. Then it is called as balanced force. Let's see the definition. Balanced force, when the net effect produced by a number of forces acting on a body, okay, is 0. Then the force is said to be balanced force. Okay, balanced force do not change the state of rest or state of motion of an object. Okay, they can however cause the change in shape of the object. Suppose there is an object of mass m and we are applying a 300 Newton towards this direction and 300 towards this direction. It is at rest, so it will remain at rest only. So F net is what? 0. Is it clear? So this is balanced force. Okay. Unbalanced force means when the net effect produced by a number of forces acting on a body is non-zero, then the force is said to be unbalanced. Okay, let's take example. A body of mass m is there. Okay, in this direction we are applying 400 Newton and in this direction we are applying 200 Newton. So what will happen? 400 Newton is more than 200 Newton, is or no? So body will start moving in this direction. Is it clear? So they can cause a stationary object to start moving. Is it clear? And they can change the speed or direction of a moving object. That is about unbalanced force. So we can say in this case, F net is not equal to 0. If net forces acting on the object is not equal to 0. Am I clear? Now, try to understand what is a dynamics. Dynamics is nothing but a branch of physics or branch of mechanics which deals with the study of an object, okay, in motion. You can see branch of mechanics which deals with the study of motion of an object. Which deals with the study of motion of an object by taking into the consideration the cause, that is force which produces the motion. Am I clear? Now, here few like in briefly, okay, we have to study, we have to learn friction also. What is friction? Generally friction is an opposing force, yes or no? So it comes into play when a body tries to move. Okay, yes or no? You can see the definition. Friction, it is a force which acts between the two surfaces in contact and opposes their relative motion or tendency of such a motion. Is it clear? So whenever we walk, yes or no? So there is a friction developed between our leg and the ground, yes or no? So this force always act in the direction opposite to the direction of motion. Suppose a body is moving, okay, a body is moving in this direction. Okay, so friction will be acting in the opposite direction, frictional force. Okay, this force always act in the direction opposite to the direction of motion, and it depend upon the nature of surface also. Am I clear? So here, if you apply, an object is there which is kept stationary. If you apply a force in this direction, okay, so frictional force will be in the opposite direction. So what is the cause of friction? You can see it arises due to the interlocking of irregularities present on the two surfaces in contact. Okay, so there are, if you see with the help of electron microscope, so the two surfaces, okay, which are there, so there will be irregularity, okay, on this surface, in this surface. So while moving, they get interlocked. So interlocking of irregularities present in the two surfaces. This is the surface of body, okay, of mass m, okay, and this is the ground, okay, so this will have irregularity. So when they try to move, these surfaces get interlocked, irregularities get interlocked. Okay, now, so basically we have three types of friction: static friction, okay, which comes into play when the object is at rest; limiting friction when the body is at the verge of moving; and dynamic friction when the body is actually moving. Okay, it is of two types: sliding friction and rolling friction. Thus, just you should have the idea. What are the uses of friction? Generally, it is used for walking, writing. Okay, we are able to write it due to the friction between the pen and the board. Yes or no? Driving, braking, lighting, matchsticks, climbing. Okay, yes or no? And is it clear? Friction has some demerits or disadvantages also. Like it will lead to the wear and tear. Okay, now fine, of the shoes. Okay, soles actually of the shoes. It causes some heating effect, okay, due to the friction. Okay, machinery parts get damaged. Yes or no? So this is the harmful effect also is there. Next, inertia. What is inertia? Okay, when we talk about inertia, it is the property of the body due to which the body opposes the change of its state. Okay, the literal meaning is what? Laziness. Inertia means what? Laziness. So it is the property of the body due to which it resists any change in its state of rest or motion. Okay, the inertia of a body is measured by the mass of the body. If the mass of the body is more, inertia is high. Is it clear? Yes or no? So inertia is of three types basically: inertia of rest, inertia of motion, and inertia of direction. So inertia of rest means what? The tendency of a body to oppose any change in its state of rest is known as inertia of rest. We have observed this also in our day-to-day life. So when a bus suddenly starts, okay, moving forward, then the passengers in the bus fall backward. Suppose you are sitting in a bus, okay, and bus suddenly starts. So what happens generally? We fall backward. Why? What is the reason? So when a bus is at rest, your body is also at rest. When suddenly bus starts, so bus comes into motion, but our body is still in rest. It has inertia of rest. Yes or no? Due to which only it falls backward. Okay, it falls backward. Similarly, when the carpet is beaten with a sticker, okay, to remove the dust particle. Okay, and when a tree is vigorously shaken, some of the leaves are fall from there. So these are the example of inertia of rest. Next, inertia of motion. So the tendency of a body to oppose any change in its state of uniform motion is known as inertia of motion. This also we have observed in our day-to-day life. Okay, for example, the passenger fall forward when a fast-moving bus stops suddenly. Okay, try to understand what happens whenever you are sitting in a bus and bus is moving, suppose with a velocity of 80 km per hour. Okay, suddenly driver applies a brake, bus comes to rest. Yes or no? But our body has inertia of motion. Yes or no? So due to that, what will happen? Our body falls forward or backward. When it stops, we fall forward due to inertia of motion only. Is it clear? So a person falls forward, okay, while getting down from a moving bus or train also. And luggage is usually tied with a rope on the roof of a bus. So no, on the roof of the bus, luggage is tied actually. If it is not tied, what will happen? Due to when the bus will stop, okay, so due to the inertia of motion, the luggage may fall down. Because of that purpose, okay, to avoid this, it is tied. Next, we have a inertia of direction. The tendency of a body to oppose any change in its direction of motion is known as inertia of direction. Am I clear? For example, when a fast moving bus takes a turn on the curved road, then the passengers fall away from the center of the curved road. Try to understand. Suppose you are going in a bus, okay, and suddenly there is a right turn. Okay, sharp curve is there, sharp turn is there. So driver will take the bus steerings to the right side, yes or no? So we fall leftward side. It is due to the inertia of direction. Am I clear? Similarly, a stone tied to a string is whirling in a horizontal circle. If a string breaks, then the stone flies away tangentially. So when you take a stone tied with a string and rotate it. So suppose the string breaks at this point, okay, at this point. So as you know that while moving in a circular motion, direction is always along the tangent, okay. So at this point, direction is along the tangent. So if the object will move in a tangential direction, it is due to the inertia of direction. Am I clear? Let's talk about the Newton's laws of motion. Newton's gave three laws of motion. Okay, first law, second law, and third law. First law is also called as law of inertia. What is this law? According to this law, if a body is at rest, it will remain at rest, and a body is in motion, it will continue its motion until or unless an external force is applied. Or we can write like this also. It states that an object will continue to remain in its state of rest or of uniform motion along a straight line path unless a net force acts on it. Am I clear? This is very, very important. So one point you should remember, Newton's first law of motion is also called as law of inertia. Okay. So you may ask one question, sir, when we kick a football in the playground, so after traveling some distance, it comes to rest. Yes or no? Why? It is due to the frictional force between the football and the ground. So some force is there, which will stop the ball. Yes or no? So that is the reason. Next, before moving to the Newton's second law, you should know about the momentum. Okay, momentum is the measure of what? Quantity of motion. Okay, momentum measures the quantity of motion possessed by the body. And mathematically it is defined as product of mass and velocity of the body. Okay, so it is represented as what? P. Momentum is generally represented as P. So we can write momentum. Okay, it is a vector quantity also. Vector quantity means what? It has magnitude as well as direction. So if a body of mass m is there, consider a body of mass m is there and moves with a velocity v. Okay, so what is the momentum? P is equal to m into v. What is SI unit of mass? Mass is in kilogram and velocity is in what? Meter per second. So SI unit of momentum is what? Kilogram meter per second. Is it clear? Okay, try to understand, if the velocity of the body is 0, what will be its momentum? Okay, so as we know that P is equal to what? M into V. If body is not moving, means if a body is at rest, its momentum is 0. Am I clear? So if a body is at rest, that is its velocity is 0, so momentum is also 0 only. Next, very, very important, I am going to do the proof also of this. Okay, what is Newton's second law of motion? Try to understand Newton's second law. Okay, according to Newton's second law of motion, okay, the rate of change of momentum, is directly proportional to the applied force and takes place in the direction in which the force acts. We can write okay, force is directly proportional to the rate of change of momentum, or ulta also we can write rate of change in momentum delta p by delta t is directly proportional to the force. Am I clear? So from this only we are going to derive a F is equal to m into A. Generally this question is asked okay for 3 marks. So I am going to do the derivation once again. You can see here. Okay. So to start the derivation, okay, we have to derivation. Very important. You can mark this as 10 star. Okay, is very important. This is very important. So what I have done, okay, I have considered an object, okay, of mass m, which is moving with velocity u. Okay, a body of mass m is there, is moving with velocity u. We applied an external force on this body. Force is therefore, because of that, body has started to move with velocity v. Am I clear? So, what is the initial momentum? Try to understand. Initial momentum. You can consider initial momentum as p1 or pi. It is nothing but mass into velocity. So, mass is what m, velocity is u. Am I clear? When force is applied, so what is the final momentum? Final momentum you can consider this as p2. So is nothing but a product of mass into velocity. Mass is m only. Velocity is what? V. So what has happened when force is applied? So there is a change in momentum. Yes or no? So can we write change in momentum? What is the change in momentum? Final momentum minus initial momentum. So can we write p2 minus p1? So we can give a term in delta p. Delta p is what? Change in momentum. What is p2? M into v. And what is p1? M into u. Am I clear? Okay, now so delta p is nothing but m you can take common. So m you take common means v minus u. Am I clear? When we talk about rate of change in momentum, rate of change in momentum is what? A change in momentum by time. Yes or no? So we can write a rate of change. Okay, of momentum. Rate of change of momentum is nothing but a change in momentum upon time. Okay, so what is it according to Newton's second law? According to Newton's second law, what he told? Okay, he told that rate of change in momentum, that is delta p by t, is directly proportional to the force. It means if you apply more force, there is a more change in momentum. If you apply less force, less change in momentum. Am I clear? So this is the statement. We can continue here. So here you can see delta p by t is directly proportional to the force according to the Newton's second law. Okay, or we can write delta p is what? M into v minus u. Okay, upon t. So you can see here what is delta p. Okay, so delta p is what? This. Okay, this is delta p. M times of v minus u. So you can write using equation 1. Okay, now using equation 1. Using equation 1. So delta p is what? M times of v minus u. Okay, now that is equal to, when you remove the proportionality in physics, you have to put a constant k into f. Okay, now as we have learnt, okay, v minus u by t is what? Acceleration. Change in velocity by time is what? Acceleration. And k value you can assume as 1. So what we can write? M into a is equal to 1 into f. Or finally what we can write? F is equal to m into a. F is equal to what? M into a. Am I clear? Okay, so this is a derivation which will be asked, generally asked. Okay, now if what is the SI unit of mass? Kilogram. Consider a body of mass 1 kg is there. Okay, consider a body of mass 1 kg. Okay, so mass of the body is what? 1 kg, and it is moving with an acceleration of 1 meter per second square. Okay, now. So what is the force? Force is equal to what? M into A. So mass is 1 kg and acceleration is 1 meter per second square. So 1 into 1 is what? 1 Newton. Okay, so SI unit of force is what? Newton. Or acceleration, what is become from here also you can write F is equal to what? F by m. If force is given, mass is given, so we can find the acceleration. A is the acceleration. What is A? Acceleration. And what is the SI unit of acceleration? Meter per second square. What is m? M is the mass of the body. SI unit is what? In kg. This is the SI unit. So this is about Newton's second law derivation. Let's talk about the Newton's third law of motion. According to the Newton's third law, okay, to every action there is always an equal and opposite reaction. Okay, it means suppose if you press, okay, the wall with 5 newtons, so you will get a 5 newton. Okay, wall will also exert a 5 newton, okay, on you. So action reaction forces act on different bodies and therefore do not cancel. Therefore, when computing the net force on a single body, suppose okay, this body is there and another body is there. So this is moving in this direction, this is moving in these directions. So after the collision, okay, what will happen? This is body 1, this is body 2. So after the collision, when they collide, okay, so this will exert a force on 2 due to 1. Similarly, there will be a force on this object, force on 1 due to 2. Okay, so if suppose if it is 10 Newton, so this will be also 10 Newton. Okay, now. So this is about Newton's third law of motion. For every action, there is an equal but opposite reaction. Okay, what is impulse? See, if a large amount of force, okay, acts on a body for a short interval of time, okay, then it is called as force. Sorry, impulse. See, impulse is nothing but a force into time. Force into time. Am I clear? Okay, what is impulse? Impulse is equal to F into T. Okay, so while playing cricket, suppose if a bowler is bowling and the batsman hit the ball, cricket ball. Okay, he is applying large amount of force and that force is acting for a very short interval of time. So that time he is imparting the impulse. Right? So that time impulse comes into play. And impulse is also equal to what? Change in momentum. Impulse is equal to what? Change in momentum. Okay, it is useful for finding the numericals. How? Let's see. Okay, how it is? See, what I taught you, I is equal to what? F into T. Am I clear? Or what is I? Mass into acceleration. Yes or no? What is force? Mass into acceleration into T. Am I clear? Now, what is acceleration? Acceleration is what? V minus U upon T into T. Can we write? So T get cancelled. So you can write impulse. Put implies that here. So impulse is equal to what? Mv minus Mu. Mv is what? The final momentum. Okay, na? And Mu is what? Initial momentum. So can we write I is equal to what? Changing momentum. So numerical based on this may be asked. I hope you understood all the various concepts which is there in this chapter. Please practice once. If you have understood, please like the videos, share with your friend, and don't forget to subscribe the channel. Okay, thank you.